Good afternoon, everyone. Welcome back to MI210. Today's the lab session for the NMTran data requirements lecture. We're going to start today with a review of some of the study guide questions. Then we'll work on the homework problems and finish up with some questions that have been posted to the discussion forum. And as well as if there are questions along the way, I'll look at the questions box. Again, I realize that you don't have access to the chat box, so if everybody would please post additional questions to be answered live through the questions box on the GoToWebinar control panel. Okay, we'll start with some study guide questions sort of as the refresher from the lecture last Tuesday. Here's a question. What are the core required data items for population models in NONMEM? And what I should have done here is set these up as a poll to see what you all thought. But I'm going to provide the answers for today. For population models in NONMEM, the core requires only a few data items, if you recall. The NONMEM core requires ID because we have to be able to identify individuals and how they're grouped. It requires a dependent variable, which of course is the quantity to be modeled. And then there's the dependent variable and the missing dependent variable and the L2 item. L2 is optional, as we mentioned, and we also said that MDV is something that will be imputed automatically by NMTran. So the NONMEM core requires three of those four pieces, which is different than the use of NMTran with PredPP. NMTran with PredPP, remember now, this is where we get all of that nice value-added data pre-processing, where we can do steady-state dosing, multiple dosing, and so on. The requirements here are slightly different in that we have to add the amount data item, which is equivalent to the dose, and time. Time is necessary because, of course, everything is a chronological time sorted data set, and in pharmacokinetics and pharmacodynamic models, there's usually some longitudinal time component. So those two are required for the PredPP type models. Next question is, when is it useful to use event ID 3 or event ID 2? Well, event ID 3 signifies a data record that is used only for the purpose of resetting the entire system to 0. So that could be used if you have a crossover design and you want to apply a washout at a particular time. It can also be used if you have a study design with multiple occasions, a long study potentially, where maybe your first occasion is early on in the study, and then there's nothing for a very long period of time. Maybe there's a 6-month or a year lapse between your first set of observations and your next set of observations. Well, event ID 3 can sometimes be used to wash out, obviously if it's appropriate given the half-life of the drug, but can be used to wash out the amounts that are being counted in the compartments over that period of time. It can help to prevent floating point problems sometimes. If you're trying to carry or calculate a very small amount in a compartment that might be very far from its last dose, it might be more effective to use a reset of the system rather than trying to calculate those very small, infinitesimally small amounts that would be left over after a very long time period after the dose. Event ID 2 is used as the other data record, and this means that other, it's not a dose, it's not an observation, and it can be used to change a covariate effect. It can be used to identify a placeholder for missing data. There's a variety of reasons that we can use event ID 2, but if event ID 2 is used, then by default it will be coded as a missing dependent variable equal 1. In other words, there's no observation on that record. It's only used to carry other information. Acceptable delimiters for NMTran datasets. We can use spaces or commas. Commas are, I think, are useful to use for pre-processing, post-processing, and other tools. But those are the fields that we can use. Why is it a good practice to use a data spec document? Well, this is sort of a rhetorical question. I think we covered this in the last project, but in the last lecture. But even in our current projects, we like to use this tool just as a way to communicate, to think about the potential problems in assembling the data. Where are the weak points? Where are the missing parts of the data? Maybe we need to go back to the source data management folks and get more information. And so doing this data spec work ahead of time can be quite helpful in that regard. Okay. Let's move on now to the practice problems if there are no questions on the study guide questions. I had asked you to create NMTran datasets for 2 subjects for a couple of different conditions. And I said focus on number 2 and 3 here. Problem 1 isn't all that relevant. The reason I said that is because this is a pharmacokinetic study with multiple dosing. And usually if we're going to have that scenario, we're going to use a PredPP model library and not a $pred model. But I did create one here just to show you what that would look like. So multiple dosing, 100 milligrams, controlled release oral tablet every 12 hours. PK sampling after the first and last dose. Insert arbitrary values for concentration. Estimate the zero order rate, whatever it is, rate of release or absorption. It's the net rate is what we're going to see. And then set this up for a PRED model or a PredPP model. So I'll show you what those look like for either case. Let me pull up my examples. And I'll just expand the view here. I can even make it bigger, I bet. Okay, so this is problem 1. This is a $pred implementation. And it's kind of tricky here in that we are going to have to develop a corresponding superposition model for this multiple dose regimen. So you have to know, and there'd be some coding you'd have to do in the control stream to go along with this. But if you're just setting up the data set, here are 2 individuals, you have multiple time points, and you're recoding here every time that dose is administered. Every time that there's an observation, excuse me. That dose here is 100 milligrams, but this dose is actually a repeated dose. So there's going to have to be some information that you transfer to the prediction model using a multiple dose equation in the control stream. Okay. The important part here is that the dose here, in this case, which is multiple dose at a fixed interval, has to be present on every record, as well as the DV. Anytime there's a $pred model, all items are required on the same row. Okay, well that's not as appealing, and frankly, we wouldn't even use $pred to do this in the real world. What we would use is the improvement, PredPP. So I'm going to get rid of this one. Let's look at problem 2, PredPP. Oh, a little too big. Now think about what data items you might need in this case. I'm just going to make this one a little smaller. So we have the comment column here, which is really a user-defined value. It doesn't mean anything specifically to NONMEM, but through the $data option, we can specify that anything that begins with a C could be ignored. And so this first row here in the data set will be ignored because it begins with a C. If we wanted to comment out an individual record, we could just simply change that 0 to a C, and now that would be dropped out. We'll turn it back. So ID 3 and 2 are listed here. Let's look at one individual first. We have the dosing record here, time 0, a dose of 100 every 12 hours, and ADDL is 3 because there's a total of 4 doses here. Now the interesting part is that we know the amount, but we want to estimate the rate of input. It's a controlled release formulation, so instead of estimating a first order absorption, we want to estimate a 0 order absorption, and the way we do that is by estimating a 0 order rate. We need to define then, this is where the model is linked from the data set to the control stream. We have to define in the data set that we want to estimate rate, and that's why we give it a -1. If we had used a positive value here, that would just signify a known rate of input, a 0 order rate, into the default compartment. Okay. We have at time 2, 4, 6 here, we have observations, as well as at time 12, but you'll notice then that there are trough values along the way here because we're or approximate trough values, because we're sampling about every 12 hours. I'm sorry, we actually did 2, 4, and 6 after the trough, after the last dose. So at 12 hours, we have sampling occurring. The doses is accounted for in the dosing record here. Okay, 38 hours, again, the dosing information is accounted for here. 40 hours, that's after the third dose. So you'll see that this regimen allows us to specify all the dosing information in one row, and then we just specify the time points where there are observations. The tricky part here, the unique part, is that rate is estimated. ID number 2, we do the same thing. Specify all the dosing in one row, estimate the rate, and we make observations at times where there are observations. Covariates are just carried forward across here. This is just a baseline covariate carried across. The placeholders here are all zeros. That's okay. NMTram will recognize that those are placeholders because there's another purpose here. We have a non-zero value in the DV column, and so all of the dosing related items are assumed to be just placeholders. Okay, so that one was pretty straightforward. Any questions on that? Okay, let's go to the next problem. This one's a little more complicated. We have multiple dosing, 200 milligrams every 12 hours. The first dose is IV, and the remaining doses are oral. At 3 weeks, there's an increase allowed. We can increase up to 400 depending upon the response. So this is going to be variable across the individuals in your data set, but this information will be captured in the database, case report form, and so on. So there's sparse sampling after the first dose and at different weeks, all at the same times post the AM dose. We got a one compartment model with a half-life of 8 to 10 hours. And the reason we're identifying this is because we've got now a multiple compartment system. We need to know how many compartments so that we can number things appropriately in the CMT data item for doses and observations and so on. The reason we need to know T1/2 is to determine whether or not we might want to model this using steady state. If, for example, all doses are administered for 5 half-lives or so before any observations are taken, then we might want to just advance the system up to steady state and not bother coding all of those doses. That's why I gave you an idea for for the system half-life. We've got some arbitrary covariates. We're going to use pred-PP. And again, wanted to create a hypothetical data set, one with and one without that 3-week dose increase. Okay, so let's take a look at the example. I'm going to blow this up a little bit here. Let me just shrink a few columns. Okay. Actually, I can do this across all of them. Just bear with me just a moment. Okay, got it. So let's look at the data items that we might use. Data items here we'll need, and I'm assuming we're using clock date and clock time. Calendar date and clock time. We're using amount. Of course, we have a dose. We have an interdose interval because this is multiple dosing. We have the ADDL item here, which could be used. In fact, we're not going to use it. Instead, I'm going to use the steady state option, which is next. Dependent variable is necessary. Rate is necessary because we have a zero order input, constant rate input. And then the covariates here. These are baseline covariates that we're just carrying along. And then finally, the compartment statement. If you recall correctly, this fits that picture that we looked at before where compartment 1 is the depot, compartment 2 is the central. Okay, let's go back to the problem spec again. So multiple dosing, 200 every 12 hours. First dose is IV, but the remaining are oral. All right, so let's look at that. So the first dose is IV. That's what we've got here. So ID number 1, at time 800 hours on January 1st, we have an amount of 200. The rate is 200. So this is a bolus. This is just an IV bolus, right? Instantaneous rate. And then the I'm sorry, it's a let me see what we've got here. Yeah, it's a 1 hour infusion. So if it was instantaneous bolus, of course, rate would be 0 here. So we're going to use an amount of 200, a rate of 200 that gives us a 1 hour infusion into the central compartment. This is our first IV dose. There's no assumption of steady state additional dosing. We're just talking about the very first dose here. SS is 0, ADDL is 0. And after that first dose, at 900, 1400, 1800 hours, we have a few observations. Okay, great. Now, what happens next is that there's steady state dosing. So after the first dose, which is IV, we're back to multiple dosing. At 3 weeks, that dose is allowed to increase to 400 BID. So let's go back to the multiple dosing now and how that might be coded. So you see now at some date, a week later, we've been dosing every 12 hours. Okay, and the system's at steady state. The reason that we know it's at steady state is that the half-life is 8 to 10 hours. So let's even take the extreme here, 10 hours times 5, that's 50 hours. So by the time a week rolls around, you've achieved steady state. So that's reasonable to assume here. So we'll say at the next week, you've achieved steady state. Remember, steady state tells you about what happened in the past, not what's happening going forward. So after this last steady state dose at 8 a.m. on the 8th, the system is up to a steady state value that would have occurred given 200 milligrams every 12 hours. And the following observations are made at 900, 1400, and 1800 hours. There's no dosing going on now between 800 and 1800. Okay. Now, 3 weeks later, so the 22nd here is 3 weeks, this is where the dose adjustment is possible. And at 3 weeks later, there's the option to move up to a higher dose. Well, this particular individual, as you see here, amount is 200, amount is 200. We don't raise the dose. But what we're saying then is that at 3 weeks, you're still at steady state, and it's on the same regimen, 200 every 12 hours. Okay. The reason you need that second steady state record here is because there were observations before that. So anytime you have a group of observations, you need to initialize the system up to steady state. Then you make the observations. So that's what we're doing here, is the week 3 steady state dosing record. Then we have the observations. Okay, so there's no doses going forward again. Remember, this is all going back. This 8 o'clock here is the last of a series of steady state doses. And then later on, they're also making some observations. This is a month later. And there are, again, 3 observations taken after a steady state dose. That steady state dose was based on a 200 milligram every 12-hour regimen. Okay. Now keep in mind here that what we're doing for all of these oral doses is that they're dosed into compartment 1. The first dose is dosed in compartment 2 because that's the central compartment. That's an IV dose. But subsequent doses are oral. So they're dosed into compartment 1 in each case. And of course, compartment is 2 for all the observations because our observations are plasma concentrations which we're observing from the central compartment. All right, so individual number 1 is sort of straightforward. Individual number 2 is a little tricky because individual 2 is one of those that changes dosing throughout the system. So let's look at that. Again, I'll go back to the details. At 3 weeks, a dose increase is allowed. We're going to go from 200 to 400, depending upon response. So this second individual has an increase. The increase starts at week 3. So how are we going to code that in the data set? Well, let's see what happens. We'll scroll down to individual number 2. Well, number 4 is what we've labeled this one. Oh, let me do this. I'll just do it this way. Okay. Here's individual number 4. So to start off, individual number 4 gets a dose just like individual number 1 did, 200 milligrams at a rate of 200, so it's a 1-hour infusion into the central compartment. The next week comes in again at steady state on oral dosing now. We know it's oral because it's compartment 1. It's at steady state on a regimen of 200 milligrams every 12 hours. Okay, so this is the steady state record that brings you up to steady state, and we make some observations. Okay. The next time, this is week 3. So this is the week when the dose change is made. When they come into the clinic on week 3, they take a response, and then they adjust the dose. So how do we code this? Now you might think I have a typo here because I've coded the dose as 200 every 12 hours, even though there's a dose increase at week 3. And that's because the steady state item here is not telling us about what happened after that week 3 visit. It's telling us about what happened in all of the days before week 3 up to steady state. So the dose wasn't changed until after that week 3 visit. And so any observation you take on day 3 is going to be based on the 200 milligram dose still. So we have the 200 milligram at steady state every 12 hours, make the observations, and then the next dose, if they were going to have one, might be an increase to 400. But we don't have to worry about that because, at least at this occasion, we don't have any observations taken after the dose increase. But then we move on to the next month where they're on the new regimen, and now we want this steady state to reflect the 400 every 12 hours because that dose has been changed. They've been on it long enough to achieve steady state, and so now it's a 400 every 12 hours steady state oral dose with some PK observations afterwards. Okay, so this is the tricky part, and it's always something you need to think about when using steady state, because if on a particular occasion a dose might be changed, You still want to make sure that the steady state dosing record has reflected what happened in the past. Steady state tells you about what happened in the past, unlike ADDL, which is projecting doses to come in the future. So those two are different, and it's something that lots of folks, when they're starting to work in this area, get hung up on. Just remember that the steady state describes the dosing history that happened in the past up to the current time, whereas ADDL happens additional doses that are going to happen in the future. Okay, so hopefully that's clear why we didn't change the dose to 400 at the trough on week 3. We waited until after they've been on the 400 up to steady state. Okay, so that's one question about steady state. I know that both in the live questions here and also through the discussion, there's been questions about steady state and how does it work. There's another question that I was going to address that I just saw come across today on the discussion board that I'll pull up now, I guess. But if there are more questions, or if this isn't clear, please take the time right now to send me a question through the dialog box. Okay, so let's pull up the discussion board. And this is something that I added to this thread. So there's a lot of discussion here. Maybe I'll hit on a few of these just in case you all have not been following. But can you use ADDL even though we're at steady state? Can you give a scenario in which we would use SS2? Well, so the first question there is, yes, you can use additional dosing after bringing the system up to a steady state. This would be for a subsequent dosing record. Okay. ADDL is not really useful in an SS dosing record because steady state reflects what happened in the past, while ADDL projects the future. There's a couple questions about SS2. What does that mean? So here's an example, and I'll address an additional example in just a minute. SS2, and maybe I need to make this a little bit larger here. Let me see if I can. Is that better? SS2 can be used if you want to achieve steady state on an irregular dosing interval. So what if you had a twice daily dosing of 10 milligrams, but the interval is not every 12 hours. Instead, it's at 8 a.m. and 4 p.m. So the interval would be 8 hours between those two, and then another 16 until the next dose. So you could code this as 2 steady state dosing records, each with a 24-hour interval. But where the second one now is coded as an SS2, so we'll add to the prior dosing record rather than resetting it to 0. So the first one happens at 8 o'clock in the morning, or at 8 hours if in elapsed time. We're assuming if it's elapsed time that the reference point is midnight. This is a steady state dose, a dose of 10, and the interval is 24 hours. And now this next dose, which happens at 1600 hours or 8 hours later, is an SS2 because we don't want this steady state record to wipe out the steady state record carried forward. This irregular interval is happening every day in a steady state dosing regimen. So we want both records to be present. If this second row here, if we had used SS1 instead of SS2, effectively it would wipe out the information in the first record, and all we'd have left is this second record. So you'd be cutting down your input by half. You'd only have one 10 milligram dose per day at 1600 hours, or at 16 hours from the reference time. Okay, so that's when SS2 is useful. So there's another question about that. Let's see. Let's create a dummy data set to demonstrate steady state in NONMEM 6 guide. I didn't pull that up, but the descriptions are right here. So it's 3 oral doses daily, 20 at 8 a.m., 10 at 3 p.m., 10 at 8 p.m. And suppose this dose cycle started on many days prior to March 9th and was continuous on March 9th and beyond. This observation was at 4 p.m. on March 9th. Okay, so this is an odd dosing scenario, but we've got two things to think about here. We've got a system to bring up to steady state, right? This cycle started many days prior to March 9th. I'm assuming that this means up to steady state, and then was continued beyond that date. So we have to do the first record to get us up to steady state, make an observation, and then create the records going forward. So let's do that. I'm going to pull this aside here so I can see it, and we'll create a new spreadsheet. Okay, so we'll have the usual columns: C, ID, time, amount, and we need steady state, we need interdose interval, we need ADDL, DV, and then the other stuff we can have, EVID, compartment, so on. We're not going to pay attention to those. The important players here are actually they're using date time, so let me insert a date column here too. Date. Okay. So there's a placeholder there. Let's look at ID1, and we'll set up the dosing records for ID1. The date, let's just put 1/1/01, and or actually they had March date, so March 9th. Okay, time here. Well, let's see. There is an observation at 4 p.m. on the 9th, but this whole system was up to steady state at 8 a.m., 3 p.m., and 8 p.m. So what we need to do is probably set this the day before, and then we would code going forward. Since that last one's at 8 p.m., we want to make sure we capture that in the steady state. So we want to set this the day before. We'll set this at March 8th. So on March 8th, we'll set up all of the steady state dosing. So this is 800 hours, or 8:00. The amount here on the first dose is 20 milligrams. That's your first daily dose. The daily doses, so that this is steady state 1. Interdose interval is 24, and there's no additional. There's no DV. Event ID here. It's a dosing event, and let's say compartment 1 in case it's oral dosing. Okay. And then we go to the again same day. Okay, but now their schedule is not it's not 8 a.m., it's at 3 p.m. So we want 12 plus 3, that's 1,500 hours. And the dose at 3 p.m. is 10 milligrams. And this is steady state 2 now because we want a superposition of steady state, 24-hour interval, no ADDL, no DV. Dose 1, compartment 1. Okay, is this starting to make sense? And then we get ID number 1 again, same date, 3/8/2010. And the time now is 8 p.m., so that's 2000. And the dose is 10 milligrams, again steady state 2, 24-hour interval, no ADDLs, no DVs. And then we have event ID 1, compartment 1. All right, so that specifies it's a single day's worth of dosing taken many days in a row for steady state. Those 3 rows specify that sort of odd schedule. The 8 a.m. 20 milligram, the 3 p.m. 10, and the 8 p.m. 10 milligram schedule. So this individual is now up to steady state. They're up to this steady state on March 8th. Now they come in on March 9th for a sample. The sample's made at 4 p.m. So they're going to continue this record. So what we need to do now is to say, okay, they're at steady state. Let's go to the next day. It's a 24-hour interval. And what we would do here is we'd say ID 1. And the date now would be 3/9. And they get their 8 a.m. dose. Again, 20 milligrams, right? Steady state is 0 now. This is not steady state. We're moving forward here. Interdose interval is still 24 hours. Additional. Well, how many additional days? I mean, let's say we're going to continue dosing for another 30 days. Okay. DV is 0. Event ID is still 1. Compartment is 1. Okay. The next dose is at 3 p.m., so that's still before the sample, so we have to dose this here. So this is 3/9. And this is again at 1500 hours. Dose of 10. Steady state now is what? It's 0. We're not invoking steady state because we've already done that on the day before. The interval is still 24 hours. And additional now 30 more days of dosing. Okay, same idea. Okay, now this is where we insert the observation. The observation was at 4 p.m. on the 9th. So we'll now move this to 1600 hours. The amount is a placeholder, 0, steady state, placeholder, or we could use 0. Either one works here. Okay, 0, 0, and now there's some number here, whatever the concentration was, 22.5. And that's an event ID 0 and a compartment 2, because this is obviously a central compartment. Compartment 1 is the dosing compartment, the depot. All right, and then we want to finish up though, because if this individual has additional observations down the road, we want to code those. And we simply add 10 milligram now. That's going to be not steady state. It has a 24-hour interval and 30 more days, etc. Dose 1, compartment 1. Okay. Now, this last dose record isn't even necessary if we don't have subsequent observations for this individual, but I'm imagining that we might have more observations down the road here. So that's how we'd set this up. So the idea here is that we use the first 3 records on this irregular dosing interval to bring the system up to steady state. Then we start the doses going forward. And so we do the initial dose plus 30 more for the first 2 time points. There's a PK observation happening between these, and then we hit the one that's at 2000 hours to continue. Now, the reason that this works is because we've already brought the system up to steady state on that 8 p.m. dose, and what we're seeing here is just the next day following that, before the 8 p.m. dose was given. That's when the sample is taken. Okay, so that's how you'd set that one up. Let me see. There's a couple questions. ADDL and steady state not commonly used in the data set. Well, maybe not, but that's not necessarily true. Here's an example of when you would use the 2 of them. Okay. If you don't know the half-life, or dosing is not consistent, then using steady state II ADDL may complicate data setup. Yeah, that's true. If you don't know the half-life, unless you've got some ballpark estimate, you can't use steady state, because steady state assumes that you know the system has reached steady state. So if you don't know that, if you don't have regular intervals, then what ends up with is that you have to code every data record as if it happened. So you would just simply have a separate record for every dose. There's no shortcuts, no assumptions about steady state, no assumptions about regular intervals. You just insert the date, time, and amount every time there's a dose. It ends up with a lot of records in the data set, but that's one way to make it work. Okay, there's another question here. Why SS2 instead of SS3 in row 4? SS2 is what's required for superposition of steady state. Okay, so you can have multiple SS2s here. Each one adds to what was present in the prior row. SS1 is a steady state which wipes out the entire system. Why do we enter 0 on the second day in the SS column? Let me see. Okay. So the reason is that the first 3 records here, this is it's not the first day. Remember, this is the day before the individual comes in for observation. This individual's been on the drug for a long time. They're at steady state. So we're just using the day before here as an anchor point to bring the system up to steady state. Now that they're up to steady state, the system amounts are all there, so the compartments are all up to the concentrations that you would expect to be at steady state. Now what we want to do is represent doses going forward from steady state. And so that's why the steady state is 0, is that we're not bringing the system up to steady state anymore. We're already there. We're just moving forward. And you'll see here that I've dosed here 1 dosing interval later than the steady state record. So the last dose at steady state was on the 8th at 8 a.m. So I have to code the next dose, which is on the 9th at 8 a.m. and then the 9th at 3 p.m. and the 9th at 8 p.m. But these are all talking about doses moving forward. We don't have to advance the system to steady state. That's why SS is 0 on those records. Okay. Any more questions? Okay, I'm going to go back to the discussion board, see if there's anything else useful here that we can grab. That was one of the more complicated ones. Okay, this was a question, is can you give an example of steady state with amount greater than 0, rate greater than 0, and interdose interval greater than 0? Well, yes, you could. Let's say it's an intermittent infusion, 10 milligrams per hour every 2 hours, given each day at 8 a.m. until steady state's reached. So in that case, you'd have an 8 a.m. regimen. It's steady state. They're already up to steady state. The dose has been a total dose of 20 at a rate of 10. So it's a 2-hour infusion given once a day. Okay, so that's an example where they're all positive. I know the steady state infusion example that I gave in the class gave us an amount equal to 0. That's because it was a constant rate infusion. It's not an intermittent infusion. And in that case, the amount of dose doesn't really matter. What matters is the input rate. Okay. So there's some good questions there. As you see, it illustrates the flexibility that we have with the NMTran PrEP type configuration, and it can certainly simplify dosing. But if you aren't sure about how long it takes to achieve steady state for a particular drug, and if the dosing records are not assumed to be taken on a regular interval, sometimes they're close enough. But if you have concerns about that, then just use the actual doses, the actual times, and code in each one as a separate record chronologically in your data set, interspersed with dependent variable observations as needed. That's how you do it. Okay, any questions now? All right, let me tell you a little bit about what's coming up here in the course. And I'd like you to be prepared for this. Let's go back to the training page. We've got next week coming up here. By the way, I'll post the solutions to the problem to the site. Next week coming up, we're going to be working with the SIMI interface, running some population PD models. We're going to take the data sets for some of the pharmacodynamic endpoints that we've talked about and build those out for a population case, and I'll explain how we do that, what to look for in diagnostics and so on. So in order for you to be ready for that, I want you to please make sure that you have checked your SIMI login, that works correctly. If you're not sure where to find that, it's right here at Metrum R Server SIMI. If you click on that link, you'll end up there. There we go, and you'll have a username and login, and you'll have something that looks like this. I'd like you to make sure that you can log in, read the NONMEM help files, for example. Try to to upload a file. You can just choose a file from your local directory, upload it. Make sure that that's all working okay, and then we'll get to running some scripts for the lab session a week from today. Okay, so that's one additional homework assignment. The other thing that's happening too is after that week we have midterm exams. So what I will do on the week of the 27th or just before that week is I'll supply the exam to you. It's just going to be a multiple choice exam. This is an open book sort of thing, but you'll have the week to work on that, and I'll be around on Friday to clarify any questions, and then we'll review those exam questions at the following week. This is optional, but if you want a certificate, if you're taking this for the certificate program and you want a certificate, you're required to take the midterm. Even if you're not taking the certificate, you might enjoy doing that just to see if we've reinforced the important points correctly. Okay, a couple more questions coming across here that we'll answer before we sign off. Okay, so one of them is why in example 4 in chapter 2 is the first record amount equal to 0. So let me pull that one up. Right here. Remember that we said this is a steady state infusion. It's a constant rate infusion. So really, we don't know how long this individual's been on that. We just know that they've been on long enough to be at steady state. So the amount is sort of unimportant here. What really matters is the input rate. In a pharmacokinetic system, if you wanted to determine steady state concentration, what you need to know are input rate and clearance. The total dose is not important here. So that's why amount is 0. It's not that the dose is 0. It's just that it's irrelevant. What really matters here is the constant rate. Okay, can we elaborate more on question 3 with the 400 milligram change at week 3? Sure. That's this one here. So subject number 4 here changes doses up to 400 milligrams after the first dose on week 3. What this dose record is telling us here at time 800 hours on the 22nd is that this is the last of a series of doses that brought this individual up to steady state. So this is telling you about what happened before the dose change occurred. Okay, so the next dose in this 12-hour interval, so we had a dose here at 2000 hours. If there was a 2000 dose, then that might be where they change up to 400. But they're not changing until they've come into the clinic here and been observed. And so what we want to reflect is that they were up to steady state on the regimen of 200 every 12 hours until that dose occurred. Remember, steady state tells us what happened in the past. That's the purpose of this example, is to illustrate that. Steady state tells us what happened in the past. In subsequent doses, they'll be up to 400, and you see that the next time they come in for some PK observations, they're at 400. Now, if we had a record in here, let's say we had some observations later, like at 2400 hours or 2200 hours, we'd want to insert a single record potentially at the new dose of 400 to represent that change in dose. But at this point, what we want to reflect is only what's happened in the past. The dose change hasn't occurred yet. It will occur at the next dose, which is 2000 hours. And that's irrelevant here because there are no PK observations after that. All these PK observations happened before that dose change. And it's not until the entire next occasion here, a month later, that we have to worry about increasing that dose. Okay, so hopefully that makes sense. A couple more questions. Let's look and see what we've got. Here's a question about the PK/PD data set where the baseline is not 0. We'll talk about that when we do the PK/PD lectures. I'm going to skip that for now. But you would do it just as you might expect. You have to initialize compartments, and we discussed that in the indirect response models. Okay, just a question about when the midterm is due. Usually we give 2 weeks to get that done. It's really flexible, but we usually give you 2 weeks. If you have a good reason why you can't get it done in 2 weeks, let us know. This is not an overly burdensome exam. You should be able to knock it out within the time it takes you to come to class, and that's why we don't have class. You could just do the midterm instead. But if you're not able to get it done within that time period, if you have an extraneous circumstance, let me know. We can make exceptions. Can you give an example of data record of SS equals 1 and ADDL equals 20 at the same time? No, you can't have SS and ADDL at the same time. If you did, it sort of defeats the purpose, because every time you have an SS1, you're wiping out the system. So you'd want to do that in 2 separate steps. Do just like I showed in this other workbook. Do the steady state stuff first, then do the ADDL. If dose is changing, okay, if the dose change is at week 3, 8 a.m. dose, can I put the at 400? Okay, so let's go back to that question. You guys are really looking for the exceptions here. So if there is a dose change at 8 a.m. on this day, now we're not accurate anymore, right? If the dose change was right at 8 a.m., this last dose wouldn't be so. So what I would do there is to insert a row, okay? And I would bring the system up to steady state on the prior dosing interval. So instead of 8 a.m. here, I would do it 12 hours before, 2000, excuse me, 8 p.m. the night before, and use that at 2. So let me do it. I'll show you. So let's say we had 2000 hours. Whoops. On the 21st. Okay. This one would be the steady state. And now, excuse me, now you would just put the dose change at 400. It would be just a single dose because we don't have to worry about additional doses here. It's every 12 hours. So this would be 0, 0, 0. Okay, so if the dose change happened right at that 8 a.m. trough, then you'd want to back up a single dosing interval, set the steady state, and give yourself the trough. That should be 400, not 4. Sorry. Okay, that's how you would do it. Okay. All right. Does that all make sense? We've covered quite a bit on data assembly here, so you should be becoming pretty good experts on this. Just another point of reference for you with respect to course requirements. If you are taking this for credit, remember one of the requirements is a small project. And the project components I'll spec out here after we get through the midterm exam. But it's really just a simple project. It doesn't have to be anything extensive, but there will be various components. One of the components will be to create a data set. And so think about maybe some real world data sets you might have, small data sets here. We're talking about maybe a phase 1 study, nothing too extensive. It could be even simulated data. But we'll start with a small data set that you will assemble correctly to represent it to NM-Tran. That's one of your requirements for the project. So think about that. If you want to get a head start, think about small data sets that you could be using to format. In addition to that, we'll actually run at least a couple of models in that data set. We'll look at diagnostics, and then you'll have to summarize some conclusions. So more details on your course project later, but you can start thinking about that now. Okay, I think we've come close to the end of our hour. There are no more questions, and I've covered what I wanted to cover here, so we'll sign off for today, and we'll pick up again on Tuesday. Please, if you have a chance, make sure that your CIMI interface connection is working fine, that your login is active, and if you have technical questions, please post those to the technical discussion list on the course homepage. Thanks, everybody. Have a nice weekend.